By the end of this video, you will have built a real AI agent in Python from scratch with LangChain. Not just a chatbot, an agent. Something that decides which tool to use, calls it, and answers with real data. This is where we are headed, the finished thing on screen. It is asked who France plays next. It picks a tool, runs it, and replies with the actual fixture, not a guess. We will build exactly that, then push it further, into an agent that streams its thinking, chains tools, returns structured data, remembers the conversation, and survives a failing API. Every line is on screen, nothing hidden, in 5 clear steps. The mental model, your first tool, running the loop, making it useful, and the production parts most tutorials skip. If you have Python installed, you will finish with a working agent, so let's build it. First, the mental model, because everything else in this video is just this one idea dressed up. A normal language model call is one shot. Text goes in, text comes out, and that is the end. It cannot check a live score, read your database, or run code. It only predicts words. An agent wraps that exact same model in a loop and hands it tools, which are just functions it is allowed to call. Now the model can reason about what to do, it can act by calling a tool, it observes the result that comes back and then it loops, reasoning again with that new information until it has a real answer. Reason, act, observe. Say it with me because you will see it everywhere. Every agent framework on Earth, including LangChain, is a convenience wrapper around that single loop. Once you see the loop, the magic disappears, and what is left is something you can actually build and debug. Setup is short, so do it with me now. We use LangChain, version 1 or newer, which is where the modern agent lives, in a function called createAgent. The older paths you will find in old blog posts, initialize, agent, and agent executor, are gone. Install LangChain with the provider you want baked in. I will use Anthropic for Claude, but swap in OpenAI if you prefer. The rest of the code is identical. Then set your API key as an environment variable. If your very first run fails with an authentication error, a missing key is the first thing to check. And finally, we point at a model with a simple string, the provider, a colon, then the model name. That string is all create, or agent needs to know which brain to use. Before we touch agents, let's feel the problem in our hands because that is what makes the fix click. Here is a plain model call, no tools, nothing fancy. We initialize the model and ask it straight up who France plays next at the World Cup. And here's the catch. It has no way to look up a live fixture. A careful model like this one will tell you straight up that it cannot access real-time data. A weaker one will just guess and sound confident doing it. Either way, you did not get the real answer. The model was trained months ago and has no live connection to the world. This is the gap that defines the whole field. A model can talk, but on its own, it cannot do. Everything we build from here exists to close that gap by giving the model a way to reach out into the real world. So let's give it a hand. Here is the good news. A tool is not some special class you have to learn. It is just a normal Python function, with one decorator on top, the tool decorator. That decorator turns your function into something the model is allowed to call. Now, the single most important part of this whole video, the docstring. This line right here is not a comment for other developers. LangChain sends it to the model as the description of what your tool does, so the model reads it to decide when to call this tool and what to pass. The type hints on your arguments become the input schema, so the model knows it needs a team name as a string. Get the docstring right and the agent uses your tool perfectly. Write a lazy, vague docstring and the agent will quietly ignore your tool and guess instead. Here is getMatch. It takes a team and for now returns a fixed string, so we can focus on the wiring. We will make it call a real API later. While we are here, let's lock in what separates a tool the agent loves from one it fumbles, because this is where beginners win or lose. 1. A clear action-verb name, getMatch, not helper or func. 2. Typed arguments, so the schema is unambiguous. 3. A docstring that says exactly what it does and when to use it, written for the model, not for you. 4. It should do one thing. A tool that does 5 things confuses the model about when to reach for it. And 5. Return a clean, readable string or simple data because whatever you return becomes the model's observation. Tattoo this list somewhere. Most agent problems are really tool design problems wearing a disguise. With a tool defined, the agent itself is a single function call. Create agent. You give it 3 things: the model string from before, a list of tools, here just our getMatch, and a system prompt, which is a sentence that tells the agent what its job is. That is the whole thing. Behind this one line, LangChain has wired the model, your tools, and the reason act observe loop together into a working agent. No loop to write by hand, no glue code. One call, and you have something you can run. Let's run it and really watch what happens because this is the heart of the whole thing. You always hand the agent a list of messages. For now, that is just one, your question as a user message. We ask who France plays next. Now follow the loop on the right. The model wakes up, sees the question, and sees that it has a getMatch tool available. It reasons and decides to call getMatch with the argument France. The tool runs and returns its result, our fixture string. That result is fed back into the model as an observation, a new message in the list. The model reads it, decides it now has everything it needs, and writes the final natural language answer. No more tool calls, so the loop stops. And every step of that, the question, the tool call, the observation, the answer, is sitting in the messages list. The reply you want is the content of the very last message. Quick but important habit. That messages list is not a black box. It is your X-ray into the agent's head, so learn to read it. Print it, and you will see the whole story in order. Your human message, then an AI message that contains the tool call with its arguments, then a tool message holding the observation that came back, and finally the AI message with the answer. When you are starting out, look at this every time. It is how you confirm the model actually called the tool, with the arguments you expected, instead of just hallucinating a reply. Most of debugging an agent is just reading this list and asking, where did it go wrong? Invoke is great, but it only hands you the answer at the very end, after everything is done. While you are building, you usually want to watch the agent think in real time. So swap Invoke for Stream and set Stream mode to updates. Now instead of waiting, you get one chunk for each step as it happens. The model deciding to call a tool, then the tool node running, then the model coming back with more. This becomes your best friend for debugging. When an agent does something weird, do not guess and do not stare at the final answer. Stream it, and you will see, live, exactly which tool it reached for and with what arguments. The bug is almost always obvious the moment you can see the steps. One tool is a neat trick. The real power, the thing that makes agents feel alive, shows up the moment you give it more than one. Let's add a second tool, getForm, that takes a team and returns its recent results. We register both in the tools list and we change nothing else. Now we ask a question that no single tool can answer on its own. How is France's next opponent playing? Watch what the agent does, completely unprompted. It calls getMatch for France, reads that the opponent is Brazil, then takes Brazil and feeds it into getForm. And only after both results come back does it write the answer. It chained 2 tools, in the correct order, passing the output of one into the input of the next, and you never wrote that sequence anywhere. That is the part that looks like intelligence. And under the hood, it is simply the same reason act-observe loop running around twice. Here is something that trips people up. The model still decides, on its own, when to use a tool. And sometimes it decides wrong. It guesses when it should have looked something up. Your main steering wheel for that is the system prompt, so be specific with it. Do not just write "you are a helpful assistant." Tell it exactly how to behave. Always call getMatch for any fixture question instead of answering from memory. And if the user did not say which team, ask them before calling anything. Watch the behavior flip. Vague and guessy before, reliable and grounded after. The system prompt is not flavor text or decoration. For an agent, it is one of your primary controls, right next to the tools themselves. Tools get a lot more capable when they take more than one argument, and when those arguments are properly typed. Your type hints are not just for your editor. LangChain turns them into a schema that the model must fill in correctly. A string stays a string, an int must be an int, and a default value makes an argument optional. And when you want full control, you can hand the tool an explicit Pydantic model as its schema, with a description on every field, so the model knows precisely what each one means. The clearer your types and field descriptions, the more reliably the model calls your tool with the right values, instead of jamming everything into one vague string. So far, getMatch returns a hard-coded string, which is great for learning and useless in real life. Let's make it real. We keep the exact same function, the same name, the same docstring, the same signature, but inside, instead of returning a fixed line, we call an actual football API with HTTPX, parse the response, and return the live fixture. And here is the beautiful part. The agent has no idea anything changed. It does not know or care whether the tool returns a hard-coded string or hits a live server. It calls it exactly the same way. That is the real lesson of this whole video, and it is worth pausing on. An agent is only ever as capable as the tools you give it. The model is fixed. The leverage is the tools. Want it to pull live scores, query your own database, send a message to your group chat, book something? You do not need a smarter model. You write a tool. Free-flowing text is fine when a human is reading the reply. But the moment you want to use the agent's output inside real code, parsing sentences with regular expressions is a nightmare and it breaks constantly. So we ask for structure instead. You define a Pydantic model describing the exact shape you want back, say a match prediction with the two teams, a favorite, and a confidence number. You pass that model to create agent as the response, yes, format. Now, alongside the usual messages, the agent hands you a real-typed object in structured response. No rejects, no string surgery, no praying the model use the right format. You get named fields, already validated against your schema. This is the single step that turns an agent from a fun demo into a component you can confidently wire into a real application. Try having a conversation with what we have built, and you will hit a wall fast. By default, every single invoke is a blank slate. The agent forgets everything the instant it answers because nothing is carrying the history between calls. To fix that, you give it a checkpointer. The in-memory saver is perfect to start. You pass it to create agent, and then on every call you include a thread ID in the config. The rule is simple. Same thread ID, same conversation. Watch. Turn 1, I tell it I support France. Turn 2, a fresh call. I just ask, when do they play next? And it remembers France from the first turn, calls getMatch on its own with France and answers in context without me repeating myself. For a real app, you swap the in-memory saver for a database-backed one. And now the memory survives restarts, server crashes, everything. Same code, durable memory. Real tools fail. That is not a maybe, it is a when. The API times out, the team name is misspelled, the server returns garbage. The simplest and safest fix is to handle it right inside your tool. Wrap the risky part in a try, and on failure, return a clear message instead of letting an exception crash the whole run. Here is why that works so well. The agent reads your error message exactly like any other observation, so it can apologize, ask the user to fix the input, or try again. You turned a crash into a conversation. And one more guardrail. To stop a confused agent from looping forever and quietly burning money, set a recursion limit in the config. It caps how many steps the loop is allowed to take. The default is 25. 2 small habits, error messages inside tools, and a recursion cap, and you are protected from runaway agents and surprise 3 a.m. bills. Now the honest part, the bit tutorials love to skip because it is not glamorous. Your agent is only ever as good as its tools and their descriptions. A fuzzy docstring, and it will call the wrong tool, or none at all, and you will swear the model is broken when the problem is your one line of English. When something misbehaves, do not guess and do not blame the model first. Stream the steps, read the trace, and see what it actually did. More often than not, the fix is a clearer docstring, a sharper system prompt, or a tool that returns a cleaner result. The model really is the easy part now. It is one line of code. designing clear tools, clear prompts, and clear error messages. That is the actual engineering, and that is where you will spend your real time. One last thing, so you know exactly where the ceiling is and what is behind it. Create Agent is not a magic black box. Under the hood, it builds and returns a LangGraph graph, a model node and a tools node, with edges that loop between them until the model stops calling tools. That matters, because it means when the standard loop is not enough for what you are building, you do not throw any of this away. You drop down one level into LangGraph and wire the nodes yourself. Fixed, multi-step pipelines, branching between several specialized agents, a human approval step in the middle of the loop. You absolutely will not need that on day one, and you should not reach for it early. But it is reassuring to know that Create AI Agent is just the easy front door, and the full power of the graph is sitting right behind it whenever you outgrow the simple version. So let's compress the whole thing into one breath: the mental model you keep. A model, some tools, a loop that reasons, acts, and observes, and a checkpointer for when it needs to remember. That is an agent. Everything else we did today, streaming, chaining, structured output, real APIs, error handling, is just you filling in those pieces for your own use case. You did not build a toy here, you built the real shape, the same shape that production agents use. So here is your homework, and I mean it. Take this, and give your agent one tool that does something you actually need, something only you would build. The full code is in the description to start from. I am Kurai Kuto. I break down one AI thing at a time, and if this made it finally click, stick around, because the next one builds right on top of this.